All right, let's dive in. Today, we're going to pull back the curtain on the secret sauce that makes almost every modern app you use feel so smooth and responsive. We're talking about task programming in C#. Ever wondered how an app can be downloading something, updating your screen, and responding to your clicks all at the exact same time? Well, you're about to find out. You know that feeling, right? We've all been there. You're staring at that dreaded spinning wheel, clicking away, and nothing. The app is totally frozen. So what is actually going on there? It really all comes down to a fundamental bottleneck in how the app is trying to get its work done. So let's look under the hood. The core issue is something we call the frozen app problem. And honestly, it's all about one single, completely overwhelmed main thread. Think of the main thread like the only employee working the front desk of a busy hotel. Now, if that employee gets stuck on a really long phone call, say downloading a huge file or running a massive calculation, they can't check you in. They can't answer your questions. The entire user interface, the entire hotel lobby, just grinds to a halt. It's completely blocked, all because it's waiting for that one single task to finish. So the solution isn't just to cross our fingers and hope that those long phone calls finish faster. Nope. The solution is to completely change how we think about getting work done in the first place. It's all about learning to think asynchronously. This analogy just makes it all click. A synchronous day is totally linear. You prepare breakfast, you wait, you get the kids ready, you wait. It's one thing at a time. But an asynchronous day, that's the day of a master multitasker. You get the breakfast started, and while that's going, you start getting the kids ready. You pop back to check on breakfast, then get yourself ready. See, multiple things are all moving forward together. Nothing is ever just sitting there, blocked and waiting. And that is exactly what we do with our code. We take that long-running work and we offload it to a background thread. This keeps our main front desk thread totally free to keep the app alive, to keep it responsive. And the most important part, the user is happy. The app never feels like it's frozen. Okay, so how do we actually pull this off in C# and .NET? Well, the fundamental building block for all of this magic is something called a task. Let's break down exactly what that is. So tasks are the heart and soul of what's called the Task Parallel Library, or TPL for short. Before the TPL came along, developers had to manage all these threads by hand, and trust me, it was complicated and super easy to make mistakes. The TPL is the modern, much smarter way to do things. Its whole purpose is to hide all that nasty complexity so we can focus on writing powerful, concurrent code much more easily. So a task really is just a promise that some work will get done in the future. It's a neat little package of code that needs to be run. And here's the key. It's a higher-level idea than a raw thread. We wrap our work in a task, and then we just hand it over to the .NET scheduler. We let it figure out the best way to run it on a background thread, while our main thread just keeps on chugging along. So why are tasks such a game changer? Well, for one, they're incredibly lightweight. That means we can have tons of them running at once without bogging down the system. Second, they give us way more control. We can easily wait for them to finish or even cancel them. And maybe most importantly, they have a really robust built-in way to handle errors when things go wrong. Okay, so running one single job in the background is pretty powerful. But what happens when things get more complicated? What if one task can't even begin until another one is completely finished? This is where you really start to see the power of the TPL. I mean, this happens all the time, right? You can't process a bunch of data until you've actually finished downloading it. You can't show a user's profile picture before you've fetched it from the server. The order really, really matters. The TPL has this really elegant solution for this problem. It's called a continuation. And it's basically what it sounds like. It's a task that's chained to a previous task, the antecedent. And it's programmed to only kick off after that first one is done. It's a way of creating a sequence. Let's use a dinner party to picture this. Task A is inviting all your friends. Now, you can't possibly start task B, ordering the food, until task A is done, right? You have to know how many people are coming first. So ordering the food is the continuation of inviting your friends. It's a perfect logical chain of events. But, the real world is messy. It's not always a perfect dinner party. And a truly robust application has to be ready for when things inevitably go wrong. Luckily, tasks have features built right in to handle these exact kinds of problems. So yeah, what happens when that file download fails halfway through because the network connection drops? Or what if the user gets impatient and decides to hit a cancel button? What do you do then? For handling errors, the TPL gives us this special container called an aggregate exception. So instead of some random error crashing your whole app, all the exceptions that happen in a task get bundled up into this one single object. Think of it like a bag that catches all the errors, giving you a detailed report of everything that went wrong so you can handle it gracefully. And for cancellation, it's a cooperative effort. The main thread doesn't just rudely pull the plug on the background task. Instead, it sends a signal, a cancellation token, which is basically a polite request saying, hey, could you please stop what you're doing? The background task then has to be written to check for that signal every so often, and then shut itself down cleanly. And it's worth pointing out that modern C# with async and await makes handling all of this stuff, continuations, exceptions, everything, incredibly clean and easy to read. So at the end of the day, when a task is finally done, it will end up in one of 3 final states. Ran to completion means, woohoo, everything worked. Canceled means it stopped nice and clean because we asked it to. And faulted, well, that means it ended because something went wrong. This gives us perfect clarity into exactly what happened with our background work. Okay, so let's bring this all back home. We've talked about threads, tasks, continuations, errors. A lot of stuff. But what is the ultimate payoff? Why does all this complexity even matter? The payoff is this, right here. When you master these concepts, you can build applications that are not just fast and efficient, but truly user-friendly. No more frozen screens, no more frustrating waits, just smooth, fluid, responsive experiences that people love to use. So, the next time you're scrolling your social media feed and new posts are loading in seamlessly without a single stutter, or you're typing in a document and it's auto-saving in the background without a hiccup, you'll know the secret. It's the silent, elegant work of asynchronous tasks, making our digital lives just that much better. Now you know how it works.